if I have a rectangle, I am multiplying area, right? Okay, so a geometric sequence would be something such as that is multiplying. Each term is multiplied by something to get the next. So we talked about this sequence yesterday. What's the common ratio? What we would call it. The common ratio is it's just 1/2. The sequence is 1 over 2 to the n, right? But the common ratio here multiplied by 1/2, right? So you have your solve the geometric sequence. Right? Geometric sequences play pretty big in power in series, which is this whole chapter. So we need to have a fairly firm understanding of what a geometric sequence is. So in general, a geometric sequence is of the form CR theta. Now, what factors can we have here? C can be a number, and we usually split these up. So if C can be less than 0, it can be equal to, let's see, hold on, let me think through this. Less than or equal to 0, it could be between 1 and 0. So you start to see all these options that you have. It can equal 1, right? And all these things change what happens here with the limit as n approaches infinity, right? And what we can do that with R as well, can't we? Right, so you can start to see all of the different options that occur. Right? We are going to consider only the cases where C is greater than 0, so we're not going to worry about all this junk. We're going to say this is true. But we are going to consider this for R, because that's really what affects things, because it has the exponent, right? So we're going to consider the different cases here. And we're going to calculate that limit, considering all those different cases. We're going to look at 5 of them. Good? Yeah. Alright, so here's the first one. What if we have the limit as n approaches infinity, CR to the n? We know that C is greater than 0, so we're going to assume C is greater than 0. We want to solve this. It's going to be a piecewise result. Okay. So we got to consider if R is between 0 and 1. We have to consider if R equals 1 and if R is greater than 1. Okay, those are created cases. And so our answers will go here. What happens if R is between 0 and 1? Okay, so let's put this in there. What if I have the limit as n approaches infinity of some value c, we'll just call it 1 here, and I have like 0.5 to the end. What is that gonna approach? One or 0? Yeah, this is a half 0.25, 0.125. It's going to go to 0, right? Okay, so that means that this is 0 if r is between 0 and 1, right? It's exponential decay. Remember that buzzword from science? Okay. All right, so we got that one. I don't even have to tell you the answer. What if r is 1? Sure. This will be 1. But what if I put a c on it? Let's say if I have the limit as n approaches infinity of 2, 1 to the n. What did you say? 2, right? Yeah, so we have to be careful there not just to say 1, but it's actually the number in front that matters the most. Okay, so this would be c. Yeah. Okay, and what if r is bigger than 1? It's going to be infinity, right? So those are your 0 and positive cases, right? Fairly easy to root out because you know how to calculate limits, right? What about the negative cases? Negative 1 to 0. And then less than or equal to negative 1. What happens here? Very similar to this. Yeah. So this would be 0 for similar reasons to this one. It's exponential decay. It just has a negative. So what about this one? Colors. Pick an R value. Negative what? That's not less than or equal to negative 1. Negative 2, okay. Negative 2. What happens is that approach? Does it? Think about this one. This is not as easy as you think. Okay, what's negative 2 to the 0? It's 1. What's negative 2 to the 1? Negative 2. What's negative 2 squared? Negative 2 to the 3rd. Does it actually approach infinity or negative infinity? No, it doesn't. It bounces back and forth, right? So it doesn't strictly approach either one. It doesn't go this way, right? And it doesn't strictly go this way. So we can't say it approaches infinity or negative infinity. We just have to say that this sucker is a pain in our butt and it diverges. Okay. So we can't say where it diverges to, but we can say it diverges. This one here also diverges, right? We can say where it diverges to. Okay. So there we go. Fun? Good word. Okay. So geometric sequences. There will be, when we work with series, there will actually be a formula for you to figure out what terms add to and all sorts of stuff. Geometric series. Next. Okay, let's see. Bounding. Let's talk about boundaries. Not those kind of boundaries, but mathematical boundaries. We talked about this yesterday, right? You see that? What was the limit as n approaches infinity of a sub n? Yeah, you'd have to switch it, right, if you were writing it out properly. But what is the answer? 0. Okay. So, if I draw a picture of this, that is not a straight vertical line. So we would have 1, 1/2, 1/4, etc., right? Okay. Is this ever going to cross 0? Right? So the limit as n approaches infinity is 0. Right? So this a sub n, this is what we would call the lower bound. I.e. a sub n never crosses that line here. It's bounded by it. It'd be like, hey Alex, what's your physical boundary between you and Mr. Jansen's room? The wall, right? Can you walk through that wall? No. You can sure try. It's not going to happen.
Oh no.
And honestly, actually, if you really, really wanted to, you could probably get through it eventually with a hammer, but it's just drywall. But
I don't know.
that's why World War I was happening yesterday, right? But, okay, so lower bound it never crosses, right? Here's what's really neat. Is this function strictly decreasing?
No, you can have a negative and you know, make it
No,
back up to the top.
we're not talking about negative. I said, is this function, is it strictly decreasing? And how would you show that? Yeah. You still have to, you can use the derivative. So we would say, it's an exponential. How do we calculate the derivative of an exponential? Or just turn it into a multiple. derivative of the exponential times the chain rule, -1. Right? Okay, so we have negative ln 2 over 2 to the x. For any x value, is that always negative? I could plug in any x value, this is always going to be negative, correct? Yes. Okay, so f prime of x is less than 0. That is an ugly less than sign. For all x values, right? Which implies f is strictly decreasing. Now, why is that important? We would say this is monotonic, right? Your book would call this monotonic. Kind of like your math teacher. Monotonic. Right. Why is that important? Bounded monotonic sequences converge. This converges to 0, right? So there's a theorem that says bounded monotonic sequences converge. Okay. So if I can't calculate this limit directly, right, but I can show it has a bound and it's monotonic, which I did here with the derivative, right, then I know that the series, the sequence will converge. It's kind of another way around the problem. If I can show it's bounded and monotonic, I know that it converges. I may not know the value that it converges to, but I know that it converges. Right? So it's kind of a handy useful item. I can say the same thing about a strictly increasing bounded function, right? So if I had something of this nature, and this is our upper bound, it's strictly increasing, monotonic, right? It's bounded, so we know that converges, right? So we can use it both ways, right? Good. Sure. Let's talk about we've probably already kind of got this in our melons, but convergent sequences are bounded. So the statement here, this is actually a theorem, so you can use it. So it's like if a sub n, some sequence a sub n converges, then it a sub n is bounded. Okay, so very simple statement, right? The reason I mention it, because I know you already probably have that difference. What part of math is working with called the converse and the contrapositive and the inverse of all these statements. So if I said this, let's see, we'll have a little true or false session, because what does that mean, right? If A sub n is bounded, then A sub n converges. This is called the converse of the original statement. So is it true or false? And if it's false, then you come up with a counterexample. Yeah, that's one vote. Anybody else? It doesn't matter if you're wrong. You don't know it.
I don't think so.
So we got two falses now. Care to throw your hat in with the winners or the losers? True. 2 for 2. You get the tiebreaker. False? Okay. If you think it's true, can you explain your reasoning? Okay. False. Explain your reasoning. Hunter?
Well, I was thinking if it converges, it has to have a boundary, so it's depending on that boundary. So if it's in front of proving the point.
You are actually. You're saying what they just said.
But it can converge onto the x-axis, which technically it could be a
You just
boundary, but it wouldn't at the same time. It can still go past it.
If it's bounded, it does not cross that line. Okay. Do you have a false reasoning? Or do you have some good reasoning for your false answer? Okay, let's hear it. What's that? Okay. Is there a function that is bounded that does not converge? That's what you're trying to figure out. If it's false, there's a function bounded that does not converge. X squared is not bounded.
What's the one that approaches the y-axis but never touches it?
What did you say? Okay, exponentials are bounded. They go. Okay, by bounded, let's say G. I see what you mean. If you go for an exponential, an exponential will go like this or come like this, right? I'm assuming you're looking at this one. Okay, this is not bounded.
But it is on the negative side.
Here.
Yeah.
Yeah, but there is no upper bound. By bounded, we mean upper and lower. I guess I should have clarified. Okay. Can you think of a function that does this? Yeah, sine or cosine. Is that bounded? Does it converge? It's just up and down, right? So you're going up and down. It's bounded, but it never converges. Right? Okay, so the converse is never true. This is just a mathematical fact. if you know that this is the converse, you can just know it's never true. Right? There's that. Contrapositive. And in a contrapositive, that would be if A sub n is not bounded, then A sub n does not converge. So you flip the statement like the converse, but you also negate both items. It's a contrapositive. Computer scientists. True or false? If A sub n is not bounded, then A sub n does not converge. Is that true? Okay, what does not bounded mean? Means it,
By your definition, that doesn't have a constant.
right, diverges, right? So if it diverges, is that what this is saying? It does not converge? Yeah. This is always true in math, in theory. Okay. So if you have a statement, converse is never true, contrapositive is always true. You can use that to your advantage, right? Use it to your advantage. Bounded monotonic. So to show something is bounded and monotonic, you can calculate the limit and the derivative. Right? Good. Any questions? So, again, point of emphasis there. Bounded means above and below. That would be something like this, right? If it's just bounded from above, it means only above. If it's just bounded from below. Okay. All right. That's it. I need to write up homework. This stuff's really unlike this. Yeah, me too, honestly. No, we're at 10.1. Prelims 1 through 5. Yeah, I've been doing all I can not to have to get up at 4:30 to go work out. And I've been successful, but tomorrow's going to be miserable.
Success.